Okay, so till now we have covered the basics of Docker, like what is the difference between containerization and virtualization, and how did the concept of containerization came into picture. Okay, plus then we saw all the Docker commands, like all the Docker related terminologies, like what is a Docker container, then what is a Docker image, what is Docker hub, and how to create command to create an image, how to go inside it, insider, and how to create an image, how to like we saw multiple ways of creating an image. We saw we could download an image from Docker Hub using Docker pull, or then when we have an image, we can run that image and it becomes a container. Okay, and we could go inside the container and we could create, and that container used to be like our normal system, like a normal virtual machine. We can use it to install anything, to create files, to do anything. Second way we talked about was creating a Docker file. So we created a Docker file. Okay, in the Docker file we wrote some commands. Okay, in the Docker file we used to specify the base image. Okay, and whatever commands you want to run inside on that base image. Okay, after creation of the Docker file, we used to just create an image from the Docker file. Okay, and when the image gets created, then like we normal used to run an image, run a container from an image, the same command we used to do, and from that image we used to run a container, and whatever we write, whatever we have written in the Docker file, everything gets uh, accomplished in the Docker container. Okay, that we have already seen. Okay, uh, any doubts on that till now, regarding Docker, the things that what we have discussed? It was clear, right? Whatever things we discussed, all the commands to create an image, to remove an image, to run a container, to build, yeah, to pull any image, to create a Docker file, all those commands that we saw. Okay, so today we'll see. So we have small two things left on the Docker. First is Docker volume, and second we'll see Docker port. Okay, so Docker volume is like we are running a containers, right? We are running containers, so we can delete the containers as well. But once the container is deleted, everything inside the container gets deleted. Correct. Even the data what you have stored in the container, that also gets deleted. Correct. So there should be some way to get the volume persisted. Okay, like you can assume, you can map it with the EC2 instance. Okay, similar to EC2 instance. So you have an EC2 instance. Okay, and that EC2 instance is let's say instance store. Okay, you know instance store, right? Shah Prakash, you know instance store volume,
Yeah. So
the volume that is ephemeral, and it's not persistent. So whenever my instance gets stopped, the everything that is there in that EBS volume, that not the EBS volume, that instance store, that gets wiped off. Okay, so that is called ephemeral. So uh, so to so in for EC2s, if we want that our volume should be persisted, in that case we used EBS backed EC2 instances. Correct. We used to create EBS volumes. Okay, so whatever gets stored in the EBS volume, we can create a snapshot. Okay, and even if we delete that uh, EC2 instance, that EBS volume can stay. Okay, it's not that EBS volume also get deleted. EBS volumes will not get deleted if we delete the EC2 instance. Okay, so these are decoupled. Okay, similar to this, we have the concept in Docker. So when a container is running, if you delete the container, whatever there is inside the container, that gets deleted. Okay, all the data gets deleted. So we have a concept of volume, that we call as Docker volume. Okay, if we have the Docker volume, then we can easily decouple the containers and the storage. Okay, and also using EBS, what we used to do, we could detach EBS from one EC2 instance and attach it to other EC2 instance, right? So the same concept we have here. So if we have a Docker volume, that Docker volume can be shared among various containers. Okay, so among different containers, you can share the volume. Clear? So that is the need of the Docker volume. Okay, you can map everything with a like uh, whatever concepts we have discussed till now about Docker, all can be mapped with an EC2 instance. Okay, what EC2 instance is to container is the same what uh, Docker volume has to do with EBS volume, and uh, what other thing that we discussed that day? There was one more thing we were mapping. Okay, so yeah, I mean everything you can map it. Yeah, AMI. Yeah, the AMI that we create for the EC2 instance. Similarly we create image for Docker. Okay, that we call as Docker image. So all these things can be mapped with each other. Okay, that is one is to one, you can say. Okay, it's not the same, but analogy I'm talking about. Okay, you can assume that it's similar. It's similar. Okay, clear? Okay,
Yeah,
so now there are multiple ways of creating a Docker volume. Okay, so for everything there are two ways of doing it with Docker. Okay, first thing is via the direct command. Okay, and second way is via a Docker file. Okay, so we have already seen these two things uh, in the last session. Okay, uh, commands also we saw, and Docker file also we saw the basics. Okay, now we'll similarly for the similarly for the volume as well. We can do it with the command and also with the Docker file. Okay, so I have logged in inside my EC2 instance. Okay, this is my EC2 instance. This is the same one that I created last time. Okay, I'm not changing anything there. I guess you could see the Docker file here as well. It is not there. So just give me a second. Okay, someone is at the door. Yeah, sorry. I guess it was at home. EC2 user. Yeah, here we created Docker file. Okay, so this was our Docker file which we created that day. Okay, so these were the things that we saw from work directory, run, comma run, then environment variable, then copy, how to copy from copy a file from my local to my container, and with the add command, I could even unzip the file. Like if there is a hello.txt and using the hello.txt we created hello.tar, and from hello.tar we created a tar.hello.tar.zz. Okay, and this file, if we use add command with this, that hello.txt that gets extracted to this particular directory. Okay, these are all things we saw in the last session. Okay, now we'll see volume as well. Okay, just let's add a few things here. That's similar to these things. There is a thing called volume. Okay, that is also a Docker keyword. So all the keywords you see, the colors are changing. So these are you cannot use these keywords in your here in your text or wherever, because these are predefined Docker keywords. Okay, from, volume, work directory, run, env, copy, add. Okay, so volume, how do we create a volume? We can create it directly like this. So this is a format how to create it. Okay, inside this, what I'll write the name of the volume. Okay, let's call it my volume. Okay, so what will happen when I create my Docker container? Uh, from this image, so this is my Docker file. Okay, if I can build an image from this Docker file, correct? So the Docker file will have all these characteristics, and what happens after I get an image, I can run a container from that image. Okay, and whatever container I am running, these all things will be reflected in that. Okay, that will be, that will use a base image called Ubuntu. That will create a volume, my volume. Okay, it will start with a temporary work directory as /temp. Okay, all these things that we already saw. Okay, so I'm just saving this file. Okay, let's see if any images are there or not right now. So docker images was the command to see the images that are present. Okay, I have some images. Okay, so let's create a new image. Okay, because since we have changed something in the Docker file, so we need to create a new image. Okay, so let's create it. So the command was docker build -t, name of the image which I want to create. Let's call it volume image. Okay, volume image I'll call it. Okay, and dot, because my Docker file is present in the current directory. Okay, so see, it is running all the so yeah, in the last session I also explained you that Docker has layered file system. Okay, Docker works on layered file system. So whatever steps we are writing here happens in the form of layers. We have 7 layers right now. So you see all these layers are executed one by one. Step 1 of 7, step 2 of 7, 3 of 7, 4 of 7. So all these steps will run by one, and they are, you see, they are creating intermediary containers. Okay, that also we saw. So after every step, a new container is getting created, and that is getting deleted after that step is complete. Okay, and the final container that we are having after all the steps are completed, that is our final image. Okay, so this is our final image. So if I again see our Docker images, so I would see volume image there. Okay, now from this volume image I can run a container. Okay.
Sorry, I'm a bit confused about this. You said there are 7 layers. So 7 layers of for the Docker, is it? I mean, to create a container. Correct. Or an image.
To create an image. To create an
okay,
image.
it's like
But
so
that
like
is
an OSI model, is it? 7 layers.
No. These are 7 steps I have written. This can be 100 layers. Okay, these can be 100 layers. These are 7 layers means
okay.
1, 2, 3, 4, 5, 6, 7. Okay, these are 7 layers I have created. Okay, so I can repeat this. I can write env multiple times. Okay, if number of variables I want to create, I can create it multiple times. These are the 7 steps. Okay, so for every step, there'll be a new layer getting created.
For every step, new layer. Okay.
Yeah.
So bit confused. Why do you want to have multiple layers in a container? Is it because a container basically will have apps? App and the binaries, or the relevant binaries and the what do you call thing? What else you require? Binaries plus
libraries, binaries and libraries.
Libraries. Yeah, there are 2 things which an app requires. So now Docker is sitting in between that, right? Between the container and your OS, or the host OS, right?
Right.
So the Docker, the layer which you're creating is within the Docker itself. These steps you have mentioned, it's about the Docker itself.
Call it Docker engine. Call it Docker engine.
Docker engine. Okay. So the steps you're mentioning, so you said multiple steps, multiple layers. So I didn't understand what these multiple layers refer to means.
Now, multiple layers refer to the steps that you mentioned in the Docker file. Okay, so as I
Oh,
told you,
okay.
right, Docker works in a layered file system. Okay, that is a characteristic of Docker. Okay,
Layered file system.
yeah,
Okay.
it is a layered file
Like,
system.
like okay.
What you are saying is like we have the Docker engine on the top of our OS. Okay, and on the top of this Docker engine, we create containers. Correct?
That's
And
correct. Yeah.
whatever we write in the Docker file gets manifested in the containers. Okay, whatever we write in the Docker files, the containers that we are going to create, that same thing will happen. So, for example, you are talking about, let's say, deploying an application in a container. Okay, so we can write it here. We can write all these steps here. Okay, so similarly, like we have written run echo hello from container. This is right. So we can write another command here. Run. After that, yum install Jenkins. After that, another line. Run, then colon, then yum install Nexus. Okay, run yum install Git. Whatever. Extra 10 things you can write it here. Okay, so all these things will be executed one by one.
So in a container, these will be executed in a container.
Right. These things will be
Okay.
these. The image is a snapshot. Image is nothing but a snapshot. It contains image just contains the directions. Okay, image
Yeah.
just
Okay. Okay. Got
contains.
it.
So I told you
Basically,
right.
okay.
Image does not contain an operating system. Okay,
Mm,
it contains just it contains an it just contains 5% of the operating system, as I told you last
mm,
time. Okay, it does not contain
mm.
the full operating system like your AMI used to contain in case of
Okay.
EC2. Okay, so when you are deploying an application, let's say you can uh, do the things here. Let's say your application requires 5 libraries. Okay, so you can install all those 5 libraries in one command. Okay,
Okay.
then you
What?
can in the
Okay.
second.
Basically, you're saying whatever things your app requires, you write down over here in the
Hmm,
steps.
correct.
Whatever libraries and
Correct. Even the libraries, even the some app might have prerequisites, right? Like creation of a user. Okay, for example, when we installed SonarQube, we created a SonarQube user, right? So let's say we are installing SonarQube in this. So what we'll do, we'll first create a SonarQube user, then we'll do something on that, give some permissions. Okay, then after that we will install SonarQube. Okay, then we can expose the port. Okay, all the things that we can do one by one. Okay, so whatever things you can imagine, like what will you do when you go inside an EC2 instance? Okay, how did we install SonarQube? We created an EC2 instance. Okay, then what we did? We created a SonarQube user. Okay, then what we did? We gave them permissions. Okay, then we installed SonarQube. Okay, then uh, then we changed some configuration files, let's say. Okay, all these things we are doing on an EC2 instance, right? We were doing all those things one by one manually. Now you can write the steps here. Okay, you can write all those steps here. Okay,
okay,
when you
okay.
execute this file, a container will be created and all these steps will be get executed. Okay, clear now?
Yeah, yeah, got it. Yeah, yeah, got it.
Okay, so here we have just created a volume. Okay, this is the additional thing that we did. Okay, so this volume image is the one that we created just now. Now let's run a container inside container with this image. So what is the command for running a container? It's docker hyphen it. Oh, sorry, docker run hyphen it. Let's name our container. Name our container can be volume container. Let's call it. Okay, then then the name of the image using which we are going to create an container. Ah, spelling mistake, I guess. Okay, never mind. We'll continue doing spelling mistakes. Okay, then slash bin slash bash. Okay, so this is so I ran a container. I'm inside it right now. Okay, now see what is the effect of this work directory. So work directory brought me to slash m directly. You see? My work directory I specified /temp. No, so now it brought me to /temp directly. Then we created a Docker volume. Okay, we created Docker volume. That was a step 2, right? This one, step 2. Okay, now if I do df hyphen h here, I should see my volume. See, you see, this directory structure got created /my volume. Okay, now you see this is file system is same /dev/xvda1. This is my volume of my EC2 instance. This is my root volume. This is my EBS root volume for my EC2 instance. Because I told you, right? Docker does not have infrastructure. This container is not having infrastructure as its own of its own. It is using the infrastructure of the host device. Correct? And what is facilitating that? The Docker engine. The Docker engine is letting it to communicate with the host device. Okay, so you see the volume. So this volume got created. Now let's create something inside the volume. Okay, I can okay, so now my uh, this image got created. Okay, now let's do one thing. uh, so yeah, one thing is, like I told you, right, we can share a Docker volume with other containers. Okay, so to share a volume with other containers, we have to create the volume first, correct? So that's the first step is done. First step is we created a Docker volume. So /my volume is my Docker volume. Okay. Now let's go inside the volume and create some files. I'll go to my volume. Okay, and let's create some files. I'll do touch a dot txt, b dot txt, c dot txt. Okay, 3 files I'm creating inside this volume. Okay, now let's exit from this container. Okay, we have exited from this container. Now we are back to our host, like our EC2 instance. We are back to our EC2 instance. Okay, so now you do not see my volume here. You see, /my volume was inside my container. It was not inside my this. It's not inside my EC2 instance. /my volume is inside my container. That was my container volume. Now what will I do? Let's share this volume with another container. Okay, for that I can run any container. Okay, I can uh, let's run a container from okay, let's run any XYZ container. Okay, I'll do a Docker run hyphen it. Okay, then hyphen name. Okay, I'll call it uh, what should I call it? Container X. Let's call it container X. Okay, container name is the container X, and let's create this container from Ubuntu. Okay, I'm not creating this container from the image that I created. Okay, I'm just creating the image from container from the base image. I'm not creating the container from this image, volume image. Okay, because volume image is already as a volume, correct? So I want to share that volume with a new container. So I'm creating this container from Ubuntu. Okay, the same command bin/bash. Okay, this is the command to run a container. Now there are some additional things in the command that you will need. Okay, so the first thing that you want to write is we want to share the volume, right? We have to specify from where you are sharing the volume. Okay, so the command to do that is hyphen volume volumes from. Okay, so you have to write volumes from. Okay, from which container? There is a container which we already ran just now. What was the container? Volume container, right? Volume container. So we are just sharing the volume from this container. Okay, and we have to give all the privileges. Okay, so there is an additional parameter called hyphen hyphen p privileged privileged. I think spelling is privilleged. Okay, privilege is equal to true. Okay, so this is a command to create, to share a volume. Okay, so what we did, we created a Docker file. I'll repeat it again. Okay, first we created a Docker file. So our Docker file had, through the Docker file we created in volume. Okay, in the Docker file we specified that the container that we are going to create will have a volume called my volume. Okay, we ran a container. Okay, we ran that image, and that image became a container, and inside that container we saw that my volume was present. Okay, and now inside the my volume we created three files: a.txt, b.txt, and c.txt. We exited from the container. Now we are creating a separate container from any other xyz image. Okay, let's say it Ubuntu. We are creating a image from from Ubuntu base image. Okay, now we are writing uh, in the existing run command that we used to have, we are just adding these two conditions, these two options. Okay, first option is hyphen hyphen privilege is equal to true. That means the container that you are going to, the volume that you are going to share, this container will have the privilege to it. Okay, the container X, the new container which you are creating, will have the privilege to the volume that is going to be shared. Okay, and hyphen hyphen volumes from. Okay, this means you are sharing the volumes from which container. So we are sharing the volumes from volume container which we created earlier. Clear? Now let's run it. I think spelling is wrong. The new spelling was wrong. Uh, PRI. Yeah, I'm no double L. So now we are inside the container, inside the new container. Okay. Now let's see if the volume was is shared or not. Now if I do D, I did not create. See, I did not create a volume for this container. Okay, I did not create a my volume for this particular container. I created a my volume in my volume container. Okay, now I have just with this command, I am creating a new container. I am with just two parameters which are specifying to share that volume with this. So I'll do a df minus h. You see, my volume is present here. Okay, so if I go inside this my volume, you will see all those files here as well. Got it? So now this particular this particular container, this particular volume is shared among two containers. Okay, two containers means the volume, the container which I created just now, container Z, and the first container that I created, volume container. Okay, now whatever command, whatever changes I do in this file will be reflected in both, in this, because the volume is the same, right? Whatever I get change anything here, since the volume is common, it both the containers can see it. Okay, similarly this container, this volume can be shared with multiple containers. Okay, you can share this volume with multiple containers with the same command. Clear? Clear, Prakash Shah?
Yeah.
Okay, so this was method one. Okay, so we have another method of so we use this we used a Docker file method, right? We created a volume. We created a Docker file. In that Docker file, we specified uh, in that Docker file only we specified this volume, right? This volume. Okay, and we created an image from this Docker file. So now we can do this with the command as well. Okay, we can do the same thing with the command as well. So let's create another container. Let's create it from the command, not with the Docker file. Okay, so the let's I'll use Docker run command just to run a container and create a volume with that command only. Docker run hyphen it hyphen name. Okay, I'll call this container as uh, container mm, container A. Let's call it container A. Okay, okay, this is my container, and I want to create a volume inside it. So what is the command? The command will be -v. That's it. -v and name of the volume. I can call that volume as hello volume or whatever you want. Okay, hello volume, and uh, then again the same stuff. From which image you want to create it? Let's create it from Ubuntu. The base image is Ubuntu, and /bin /bash. Okay, so this should uh, run a container directly with the base image called Ubuntu, and in this container A, there should be a volume called hello volume. You can do a df -h just to see. Yes, you see hello volume here. Okay. Now with the same image, the same you can uh, run a container, and you can share this volume with a different container. Okay, clear. So let's exit it. Okay, now uh, mm, again the command would be same. Okay, the command is going to be the same that we used earlier. Okay, so we can create another container B, let's say. Okay, container B, and privilege is, oh, sorry. Privilege is true. Volume from container. Which container we want to share? Volume from which container we want to share? It was container A, right? So we'll write container A, and Ubuntu, let's say Ubuntu is a base image. Okay. Now we are inside the container B, and we can do df -h, and it has hello volume. Okay, now hello volume is shared between these two containers, container A and container B. Okay, so these are the two things. Okay, now other thing is, let's say you want to map your EC2 directory with your container. Okay, let's say you want to map your EC2 directory with your container. So how will you do that? Okay, let's do that as well. So we are right now in /home/EC2 user. Okay, so let's map this with my um, container. Okay, so I'll create another container, let's say. So I'm creating many containers. You see, I'm creating so many containers again and again. So all these are different isolated containers. They are not, containers are not shared. The volumes are getting shared among different containers, but all these are isolated containers that I'm creating. Okay, again, I'm creating a new container. Okay, Docker run hyphen it name, sorry, hyphen name. Okay, let's call it container C. Okay. Uh, Sorry, I'm running short of names, so I'm using A, B, and C. Okay, so the command is -v. Okay, just to, and how you map it, how you map your host EC2 volume with your Docker image, with your image, sorry, with your container. So how will you do it? You have to specify which volume, which path you want to mount. Sorry, which path you want to map it. Okay, so I'll use slash, let's map this directory slash home slash is2 user. Okay, then colon and where. Here you specify the volume. Okay, here you specify the volume. Let's call it uh, test volume. Okay, let's call it test volume. And again, the command will be hyphen privileged privileged, sorry, leged is equal to true. Okay, ubuntu slash bin slash bash. Okay, so this should create my container. Okay, now inside my the container is running. I am inside my container C. Now we can do df hyphen h just to see this test volume got created. Okay, you see test volume we created. Now let's see inside what's inside test volume. Cd slash test volume. Let's see what it is. You see, it is the same content what we had in slash home slash ec2 user. Okay, so we had the same content in slash home slash ec2 user, right? Which we have already seen this. You see, this content was already there in slash home and slash ec2 user here. So we just mapped our path of this ec2 with the volume on our container. Okay, so this was the command. Clear? Clear? Prakash Shah?
Yeah,
Any doubts? It's easy, right?
yeah, which is the same steps as enough.
Yeah, you just need to remember these commands. Okay, no need to
Yeah,
remember this, but yeah, for interview and all, you can remember these. But later on, when you work on it, there will be so many things that you can do. Okay, you can always search Google, and there are so many uh, Docker cheat sheets that you can download, and all these commands will be written there. Okay, you just need to know the concepts. Okay, the concept of the volume, how the volume can be shared among multiple containers. Okay, and how the volume from our host EC2 machine can be mapped with our Docker volume. Okay, all these concepts you should know. Okay, then yeah, next is the ports. Okay, so next is the ports. Okay, so we have you guys already have the idea of networking, correct? So our EC2 instance has an IP. Okay, our EC2 instance has an IP. Now there are multiple applications running inside our EC2 instance in the form of like there are multiple containers running in the same EC2 instance. Okay, and inside every container as well, we can have multiple applications running. Okay, in a container we can have multiple applications running. So let's say a person outside my EC2 instance wants to access any application that is running inside my container. How will he access it? Okay, so we have to expose the port in that case. So if you know the concept of ports, so we can have in this on the same device we can have multiple things, uh, multiple applications running on the same device, and all applications can run on different ports. Correct. So for example, uh, you see we have predefined ports for many service. For example, for MySQL we have 3306. Okay, for NFS we have 2049. For HTTP we have port 80. For HTTPS we have 443. For SSH we have 22. So for everything we have port defined. Correct. So for everything that is running inside a machine, so that can run on a different port. So how we access those applications? If we specify the IP of that machine with that particular port, that application can be accessed. Okay, so the same concept here we have here. Okay, the same concept we are having here in case of Docker. So we can uh, expose the ports. Okay, we can expose the ports. So our application are there can be multiple applications running inside a Docker containers. Okay, for example, Jenkins is running. Okay, Apache is running. Okay, on the same container. Now, port for Jenkins by default port for Jenkins is 8080. Okay, and port for Apache is port for HTTP is 80. Okay, like Apache will run on port 80, right? By default, Apache runs on port 80. Okay, and Jenkins run on port 8080. Now both of these things are running on your same container, so you can access these with these ports. Okay, from outside from a web browser, you can just provide the IP of your EC2 instance and just mention the port. If you mention port 80, your request will be sent to Apache. Okay, and if you mention port 8080, your request will be sent to Jenkins. Okay. So there are two things here. Okay, one is expose. Okay, and other thing is publish. Okay, expose means, so you can we say you can expose a port. Okay. So what does expose mean? So let's say your application is running inside a container. Okay, let's say your Jenkins is running inside a container. So if you expose a port, if you expose that port, so multiple containers running inside the same EC2 instance can access it. Okay, assume listen carefully, there's a small difference. Okay, so if you expose the port, let's say you have 10 containers running inside an EC2 instance. Okay, you have 10 containers running inside your EC2 instance. Now on container A you install Jenkins. Okay, and Jenkins runs on port 8080. Okay, now if you expose the port 8080, then Jenkins can be accessed from other containers. Okay, it cannot be accessed from outside. If you do it a request from a browser from your laptop, the request would fail. Okay, because you have just exposed the port. Oh, expose the port means it's available only to the containers that are inside that EC2 instance. Okay, inside the EC2 instance it is available. Okay, so to make it available to the outside world, you have to publish it. Okay, you have to publish it. So publishing we do using the port using -p. Okay, there is a parameter called there is a parameter -p option. So using this, you expose, you can publish the port. Okay, if you publish it, then that particular port, that particular service that we are going to expose using that port can be used from outside the world as well. Okay, clear about the difference. So yeah, if I publish the port, obviously it will be accessible to inside the containers as well, right? If there are other 9 containers, for that also it will be exposed. Okay, so that is the difference between expose and publish. Okay, so that is one of important thing. Okay, it is frequently asked in interview as well. What is the difference between expose and publish? Okay, so expose is, if we expose a port, that means it is available to it is available within my EC2 instance. Okay, within the host machine. Okay, and there can be hundreds of containers running inside my host machine. Okay, and that particular port will be exposed only to the containers that are running inside my host machine. That's it. But if I publish it, it is available to the outside world as well. Okay, an outside world, if it is available to the outside world, obviously it is available to inside in containers as well. Okay.
Yeah, got it.
Okay, so let's do it with the with some yeah, okay, let's do some demo. Okay, I should have many containers right now, I guess. So ps hyphen a, oh sorry, if I do docker ps hyphen a, oh, I have many containers. Okay, let's keep that running. We'll keep on creating containers. Okay, so now let's create another container. Okay, let's use this, how to use this publish thing. Okay, so the command, let's create some other containers. Docker run. Okay, so till now we did hyphen it, correct? Hyphen it was interactive and terminal. Hyphen I means interactive and T means terminal. Okay, interactive means I want to open it. I it brought me directly to inside the Docker container. Correct. But let's say I don't want to go directly inside Docker container. I just want to run it. Okay, I just want to keep the Docker container running. I don't want to go inside it. And I told you last time, right? What is the command to go inside Docker? If that container you see running, you can do docker attach and the name of the container. And with that command, with you can directly go inside the Docker container. Okay, so but if we want to keep the just run the container, if you want to just run the container, okay, not go inside the container, just run the container. So instead of I we can put T. Okay, TD. Okay, instead of it we can put TD. Okay, then hyphen name. Okay, let's name this container as container D. Okay, and let's expose this port now. Port 80 80. So this is how we expose a port. Okay, 80 means this is refers to my host machine, and this refers to my container. Okay, this is a mapping that we are getting, that someone, the request coming to port 80 will get redirected to port 80 on the container. Okay, so Ubuntu, yeah, spelling is correct. So that's it. I don't want to do slash bin slash bash because I don't want to go into the interactive mode. Okay, so see, it has run the Docker container, and now if I do uh, so yeah, there is a command to check the port. Okay, to get the information on the port that are uh, that have been exposed, that have been published. Okay, for a particular container. So the command is docker port name of the container. See, the commands of Docker are very easy. Okay, very self-explanatory. Okay, you see, these ports are open now. Okay, 80 TCP open to the outside world. Okay, since we did -p, now this is not only open to the containers that are running inside EC2 instance, but it is also exposed to the outside world. Okay, now let's let's okay, let's go inside this container now. Okay, let's go inside this container now. Okay, how to go inside this container? We can use docker attach. Docker attach. I'm writing, doing a lot of spelling mistakes, but yeah. Okay, I'm inside my container now. Okay, let's. What happened? Okay, let's run a few commands here. I'll do apt get. Let's install something. Okay, let's install something. Apt get. Uh, install Apache 2. Let's install Apache. -2 -y. Repeat get install -2. Okay, so I'm inside my container right now. Okay, all these commands which I'm executing, executing inside my container right now. Okay, let's not do attach. Okay, let's go inside the container like with the exec command. Okay, we had this docker exec command also, right? So docker exec. So this is also command. Okay, this is also a command to execute. Uh, exec means execute. Okay, to execute it in an interactive way. Okay, because I want to run few commands there, so I want to run it in an interactive way. I want to go inside the docker container in an interactive way. So docker exec -it and name of the container. Okay, now run a command. Docker exec requires at least 2 arguments. What is it? Docker exec -id docker exec exec command is correct. Run a command inside the container. Why is the docker command not running? Docker exec. Let's check if we have this container as well or not. Docker ps-a. Okay, we have this. We have this command. We have this container. You can see the ports as well, and the name of the container is container. Did I do a spelling mistake? Spelling mistake is here, but I used the same command. Wait, let's try again. Docker exec -it. Let's copy this name. Docker exec requires at least 2 arguments. Okay, let's see what is it saying. Docker exec options. It's asking to run some commands inside the container. Mm, it should work actually. I wrote IT, so it should run in the interactive way. Docker exec. Why is it asking for a command as well? Command as well, it should not ask. I want to run this command, run this container in a interactive way. Okay, so let's run it from here only interactive way. Okay. IT, the same thing I'm using like I used to do earlier. So just td was a command. I wanted to show you that td was a command. If you don't want to run an interactive way, you can use a td. That will run your container, but not in an interactive way. Okay. So I guess I need to stop this container as well. But yeah, let's create a new container. I'm creating a new container, container E. I'm creating a new container, container D, because I don't want to stop the container D. Let it run. Okay. Or let's stop it. I don't want the port and all those issues. Docker ps. Okay, this is running. I'll do. Now it got stopped. If I do docker ps, I do not see any docker containers. Now let's run this container. Okay, docker run. I'll do -it hyphen name. The name of the container is container d. Let's call it. Okay, -p 80 import 80 port I'm exposing Ubuntu. Okay, then /bin/bash. Okay, now it will run my container in interactive mode. Container name /container d is already in use. I have to remove the container first. Yes, I can. Okay, now container D is not there. Now I can run this command with peace. Okay, now I'm inside my Docker container. Now what I want to do, I want to just run some commands there. Okay, let's install Apache. I wanted to install, right? apt get update. Sorry, apt get. I'll not update. I'll just do install Apache PSH2. Okay, hyphen y. Okay, so this installed, unable to locate the package Apache 2. What is the name of the package? Ubuntu. Okay, let me search what is the name of the package. I forgot the name of the package. I just want to write the correct package. That's it. Accept all and set the site. Is there right? Apt install Apache 2. What? It is not able to locate the package. Will it find yum? Mm. Okay, let me do update as well. apt get. Let's update it first. Now let's see if it is able to find it. Watch it do. Now that OS was not updated. Sorry. Okay. Um, so you can install anything. I'm just giving an example of installing something in the container, and I'll expose that application to outside world. Okay, so I installed Apache. Okay, I installed Apache 2, and here, uh, like you must have already done in your when you were creating an EC2 instance to check the load balancers and things. You must have done it, I guess. Install Apache, and then in slash var slash www slash html we used to create a file index.html, and through the URL of the EC2 instance we could see it on the browser. Correct? You might have done that, right? So the same thing we are doing here, nothing different. Okay, so we
Okay.
came inside the container, we just installed Apache. Okay, now we are doing the same thing. Now we'll go to cd var www html. Okay, inside this HTML, we have index.html already. So in the index.html, uh, we can edit it. Okay, just to what is inside. Vi command is not found. How come? No worries. We can do whatever we want to print inside it. Okay. Echo hello from inside the container. Okay. So okay, and I'll put this thing inside my index.html. Okay. Okay. So what I'll do, I'll just now I have to stop and start Apache. Correct. So what I'll do service Apache to start. Okay. Now the service is started. Mm, Okay. Okay. Now let's see if I put my public IP of my EC2 instance. You can see my browser, right? My Chrome, you can see. So I'm
Yes,
just
yes, you can see
putting
it.
my public IP of my EC2 machine. Incognito. Let's open incognito. Okay, and port 80. 80 is by default only, but yeah, see, this thing came here. So this is the thing from inside my container now. Okay, how did this happen? Because I exposed a port. Okay, when I was while creating this container, I exposed a port 80. So this port 80 was available to the public. That means from the browser, it was exposed. It was published. Okay. Now how it is mapping? It is mapping to port 80. Port 80 of my EC2 machine is being mapped with port 80 of my container. Okay. And on port 80 of my container, there is Apache running. Okay. Got it?
Yeah, yeah, got it.
Now you can do multiple things here. Okay. Now let's mm, let's expose one or two ports more. Mm, okay, what I'll do. How to show multiple ports now? Mm, So what else? Like similar to this, you can export multiple ports. Okay, not only 8080. Uh, mm, let's say you have, let's install Jenkins as well. Maybe. Just give me a second. What is the name of the package? God. You can take some time to digest as well. Just give me 2 minutes. Searching the name of the package. That's it. Till here it's clear, right? Jenkins is only the name. Okay, so yeah, the see, I will show you how this mapping is working. So you understood this command, right? Port 80 of my host machine is being mapped with port 80 of my container. Okay, now similar mapping you can do port for different ports. Okay, so if I exit, okay, let's exit from here. Okay, I'm exiting from my container. I'm back to my EC2. Now let's create another container. Uh, we can create another container. Let's create a Jenkins container now. Okay, and we know the Jenkins container. Jenkins will run on port 8080. Correct, not on 80. It will run on 8080. So now let's run that container. Okay, Docker run hyphen it hyphen it. Uh, then hyphen name. Okay, I'll call it Jenkins container. Okay, and how will I expose the port? I'll use -p the same way. Okay, 80 80 80 80 of my browser, 80 80 of my EC2 instance is pointing to, is mapped with 80 80 of my host machine, sorry, of the container. Okay, this refers to my EC2 instance, like my host machine, and this refers to my container port. Okay, now if I do Jenkins, okay, this is my image name. Okay, Jenkins is the name of the image that I was searching for. Okay, uh, slash bin slash bash docker run id name Jenkins slash bash. Okay, now if I manifest for Jenkins, oh, unable to find Jenkins. Jenkins is not there. Ah, it says unable to find. See, unable to find image Jenkins locally. It's not available. Okay, so we need to pull it. So I'll do docker pull Jenkins. Using default tag error response on the daemon manifest for the latest Jenkins not found. Manifest unknown. What is it? Docker pull. Okay, I'll have to go to Docker Hub and then see if Jenkins with what name Jenkins package is available. Uh, Docker Hub. Jenkins should be there. Jenkins. Yeah, is there. The image has been deprecated for over 2 years in favor of oh. Mm, So on Docker Hub, you can also see how to use this image as well. So if you open an image, you will see all the directions to use it, all with all the Docker commands. Okay, so Docker Hub is very, very useful if you want to like for any other freeware, any software you want to create a container, you can just go to Docker Hub and you will see, you will find all those details. So Jenkins is there, but why is it showing deprecated? I don't know. Mm, we have the correct spelling, right? Jenkins. Jenkins. Yeah, spelling is correct. Full default. This got deprecated. Then what are these guys using for Jenkins? Okay, let's pull this. Let's use this then. This is not an official Jenkins image, but yeah, I saw that it has some good number of downloads and it has a good documentation as well, which I have not read. But yeah, it looks reliable, so I just pulled it. And it has been updated 18 hours ago and it is sponsored over OSS. So maybe that is good. Okay, so it downloaded Jenkins image. Now we just wanted to expose it, right? With our command. Okay, now we will just this command, right? This was the name of the image. We'll run this image this. So we are inside a Jenkins container. Okay, now if I open Jenkins from, now how will I open it? I'll just the same way, nothing different. I'll go to my incognito window and copy this public IP. Okay, and port is 8080. Okay, so here my Jenkins should be accessible. This side cannot be loaded. Maybe Jenkins has to be started. It is stopped right now. Okay, maybe that's why. If I do Jenkins hyphen hyphen version, we have to go to the documentation of this image maybe.
Have you enabled port 8080 for the public IP on the?
Port 8080 should be available for my EC from my this security group. Port 8080 is available. Is enabled. You see. So here port is not an issue. Jenkins is not started. So that's what I'm looking for. This official Docker image is not working. I don't know why. So that's why I referred to this one. So they are giving some instructions. Setting the number of executor, connecting the agent, passing. So documentations are pretty good here. So you can easily go in. Okay, how they are verifying the version. They are now installing more tools.
This is not official version, is it? LTS.
They are they
JDK.
are they are saying that the official which I was trying, they were saying that this is deprecated. I don't know why this.
Jenkins.
Yeah, this is deprecated. Use
Uh-huh.
Jenkins LTS instead. Okay,
Okay. Let's try that.
Jenkins and yes. This is Docker official image. Oh, they have changed it, I guess. Okay, let's use this then.
Okay. How do we remove the one that we already pulled? We don't need to remove
You
it.
can delete it. You can delete it. Docker images. If you
RM.
see,
Yeah.
we have this Jenkins image, right? You can
Yeah.
remove it. You can remove it. Docker
Is it
RMI
RM? Okay.
RM will remove the container. RMI is remove the image. Okay.
Okay.
Docker RMI name of the image. That's it.
Yeah.
It says no such image. Why does it say no such image? Oh, image ID. Put the image ID.
Okay.
Hmm. Okay. Error response. Unable to merge the force image is being used
Okay.
by stopped container. There is a container running. Maybe that's why. So I have to remove this container first. So I'll do docker rm this container. Okay, container got deleted. Now I have to delete the image. Now it will get deleted. Okay, so now it got deleted.
Okay. Yeah.
Okay, so let's use this image then. Docker pull Jenkins. But this pull command is, why is it not working? I tried, right? You see? Error
Okay.
response for daemon. It's saying use this command. Okay,
So try
use
Jenkins
Jenkins and
slash Jenkins. Yeah. Okay.
I guess it will download
And
the same thing.
LTS.
Mhm. Okay, got done. Now coming to our original command. Yeah, this. So here. mm, So this was the name of the image, right? Jenkins, Jenkins. So I'm running it on port 8080 and let's run it. Which version is downloading? We do not specify LTS, so it is pulling the latest one. Okay, let it pull.
So there's a package called Jenkins test Jenkins.
Yeah, there is a package called
Okay.
Jenkins latest as well, so it is pulling
Okay.
that. Okay, so now we are inside the Jenkins container.
Yeah.
Okay, now I need to find Jenkins hyphen version. Jenkins command not found. Why is it saying that? I do which Jenkins? Okay, that also is not responding. Okay, this should be a how do I start it now? Mm, maybe this. Now let me try. Just okay.
I mean, normally when it says connection refill, that means some kind of something is
What?
blocking, right? Hello?
Yeah. Something is blocking, or maybe Jenkins is not started. Okay,
It's not
Jenkins is
started.
not
Okay,
started.
can we
That's why.
check whether it started?
Yeah, that's what I was trying to check. So this is having their documentation. This particular image has its documentation.
Yeah.
Okay, so that's where I'm checking. Uh, it will check Jenkins home. So Jenkins home should be something here. Echo dollar Jenkins home. Ah, okay, Jenkins home is here. Okay, let's go inside this. There's nothing here. Mm, something is already running on that instance, maybe. Okay, let's check my EC2 instance. What's the thing running? Jenkins. So this 8080 port is exposed, so it should open from my browser. Why is it not opening? What's the thing? Just do docker ps -k. This was the image. Docker. It is running on port 8080 5000 DCP. Should show here. Why is it not running? It's weird. What else does it want? 80. Mm. As for them, there is no need to use the kind of connecting agents below to the port. This will run Jenkins in detached mode. Plugins. We should have written here something. Okay, the status of Docker container shows perfect. Okay, name of the image is fine. Then code exposed is fine. And that container is also Jenkins. That is the official Jenkins container that we have used. Okay, so everything should be fine. But just port 8080. Let me recheck my EC2 instance. It says port 8080 is open. This is something weird. What is blocking it? What is there should be something blocking it. Hmm. Okay, let me see why is it not working. It should work actually. We have done everything perfect. Hmm. I don't know what is image. I have never used this particular image. Earlier I used to use that image and that used to work perfectly fine. Like this. Hmm. Let's try with something else apart from Jenkins. Let's try Uh, what else? Hmm. Sona queue. Oh, they have all these requirements. We'll not be able to match. Okay, maybe our system is not meeting the requirements. Maybe. Mm, mm, It is running. It is. I don't know if Jenkins is running fine or not.
Is it running on 5,000?
No, no, no. It's running on 8080 only.
Uh-huh. What is that 50,000 they're saying? In
That
the Jenkins website,
yeah,
they're
they are
saying
running with they are running with this. That is thing with the image only. Like this image is having that thing. So
50,000.
they
Yeah.
they are showing a node. Read this section of connecting ports below for this role of what 50,000 port mapping. So I've written the reason as well.
Uh-huh.
So you can build in order to connect agents through an inbound TCP connection. Map the port minus 50,000 within this port will be used when you connect agents to the controller.
Do we need to map that also?
Mm,
There's two mappings, right?
yeah, but 50,000. 50,000. Okay, let me do it. Maybe this is happening with this image. Okay, let's do
Okay.
it. Let's do it. If that is the reason, then let's add 50,000 also in our security group. Mm,
Is that a LAN messenger? 50,000, it says, I'm just Googling. Says LAN messenger uses 50,000 TCP units. So what kind of port is it? I mean, is it
No idea.
TCP? No,
This is
50,000
it
TCP.
should be TCP only. It should be TCP only. Let's see. Let's see. Nothing bad in trying.
What application is that? You happen to know?
No, no idea.
Okay.
8080. No.
So when you're running Docker run, like how did you run? Like, I mean, a Docker run minus P 8080, and then
Same
again
command.
minus P, minus P 5,000, 50,000, 50,000, like that?
No, 50,000 I don't use. 50,000 is like the container is the image. I'm using this image, right? I don't know much about this Jenkins image. I have not used this
Yeah, yeah.
Jenkins/Jenkins. Earlier, I used to
Uh-huh.
use Jenkins official image that is deprecated now. Okay,
Uh-huh.
so that was perfect. But now they have done something about port 50,000 as well. I don't know why. But
We
some
haven't put
anyway.
50,000 in the Docker run, right? So
Hmm.
do we need to do that and try again? Yeah. So
Mm,
like it has got two
mm,
minus P.
Yeah, you're right. You're right. Maybe let's copy that command. This official site
Yeah.
was also saying something, right? About regarding this
Yeah.
command. Yeah, this command minus C minus P. Mm. So yeah, let's do this
This is
command.
JDK11, yeah.
This is the same. This is the same thing. So it
Okay.
downloaded the same thing. Okay,
So it's
so
gonna download that one.
we will just let's run it directly. Unable to
Pulling.
find the image locally, pulling it from Jenkins. Error response driver failed. Programming external connectivity and bind for 8080. Okay, port 8080 is already allocated, right? For that.
Uh-huh. Uh-huh.
So we have to delete the container first. That this container we have to delete it. Docker stop. Sorry. RM. You cannot remove a container running container. Yeah, so this container is running. This container is running, that means Jenkins is also running. We are not able to access it. Docker stop thing. Yeah, it's about 50,000 I guess now. Okay, it got removed. Now in Docker image, if I do Docker, I should not see Jenkins. Okay. So status is created few minutes back. I don't care. There's nothing mapped there, right? So I'll just run that command again. Yeah, this. Now it is starting Jenkins as well, I guess. Now it started Jenkins initial setup is required. Okay, now if I access it from my browser, it should be available. Okay. Oh, here only I can just refresh. Yeah, it is there, starting Jenkins. It was over port 50,000 also, right? Thanks for that. Okay. So, so this was the whole thing I was telling you about expose the port. Okay, that took a lot of time. That small thing. Okay, that depends on the image. Okay, that totally depends on the image. Okay, if you open Docker up, you will just find that image and you will see all the directions how to expose it. So it is exposing two ports. Okay, port 8080 of the uh, host with port 80 of the container, and also it is exposing port 50,000 to port 50,000. Okay, I am still not clear what this 50,000 is for, but yeah, if you have any more, if you want to read more, you can you can go to this and read about it. What is connecting agents and what does that, what or why is it 50,000? Okay, I'm not explaining it because it might vary from image to image. Okay, for this image is 50,000, for other things it can be something else. Okay, so we don't care about it. Okay, so yeah, just wanted to highlight it. So 8080 is the port expose for Jenkins, and you see also we had a Docker image, I guess that is stopped right now. Oh, sorry, I don't want to do here. I'll create another duplicate instance. Easy to hyphen user. Okay, so su Docker ps. Okay, here we created one more image, I guess. One more container we created. That was on port 80, correct? What was it? We removed it or what? Container D, which was the port? Yeah, I guess container D was the port that was export to port 80. Okay, so I just meant to say that on the same EC2 instance on port 80, your that container will be accessible, and on port 8080, your Jenkins container will be accessible. Okay, so you can have multiple containers running on multiple ports. Okay, so based on ports, so it will be applicable in the case when you have multiple applications deployed on multiple containers in your EC2 instance. Okay, you can have 5 containers in your EC2 instance. Okay, they can have application A, application B, application C, application D, application E. Okay, all these 5 uh, containers can have different applications. Again, all these applications might be available on different ports. So you can expose different ports of the host and map it to different containers. Okay, so if the port is repeating, you will get an error like we just got. The 8080 is already in use. Okay,
Okay, so you can't have duplicate ports, right?
correct.
So if
You cannot have duplicate ports. But yeah, you can have yeah, right, you cannot have duplicate ports. You cannot have, the port has to be one to one mapping, else it will get confused.
by the VM, right? I mean,
Correct, from the
virtual
host.
machine.
from the host, yeah, virtual machine.
Yeah.
Okay, but we'll see more in detail when we are studying Kubernetes. Okay, in the next session when we are studying Kubernetes, we'll see a lot of those things. Okay, so we are done
Okay.
with we are totally done with Docker now. All these basic things
Yeah.
and all the major things that are done. So now more complex things are pending. So there are other things in Docker, but the basics and everything, it will depend on all these basic things only. Okay, all these
Yeah.
pending things. So there is a certification for Docker as well. So there is a 20-50 hours of course of only on Docker. Okay, but this is like you're good to know like work on Docker now. Okay, like the basic
Okay.
thing when what is being used in industry. Okay, you can
Mm.
with the things that we have discussed, it's more than what you require. Okay,
Is Docker certification required nowadays?
you can do it. It's like you can do or it's fine. Like Kubernetes
Okay.
certification is people are doing these days. Okay, Kubernetes
Okay.
certification.
Yeah, I mean, what certification do we need for DevOps? I mean, we don't have any one certification, right?
So the thing is, DevOps is you have different tools. Okay, and different tools are
Uh-huh.
different certifications. For
Uh-huh.
infrastructure as a code, so that also comes in DevOps. So you might
Uh-huh.
have studied cloud formation, correct?
Uh-huh.
So you have Terraform as well. That is the same thing,
Yeah.
similar to cloud formation. Okay, so Terraform has its certification, HashiCorp certified Terraform
Oh, yeah.
developer or what.
Can't do everything, isn't
Okay, you
it?
can do that. Plus,
Yeah.
then AWS DevOps certified you can become. Okay, AWS DevOps
Uh-huh.
certification that is also there. Then for especially for Kubernetes, there is a certification that is very popular these days. CK8d,
Uh-huh.
certified Kubernetes administrator, certified Kubernetes developer. Okay,
Uh-huh.
CKA courses you have many, so you can
Uh-huh.
go for that. You have Docker specialized courses as well,
Uh-huh.
certifications as well. So yeah, I would if you want to go for certification, I would suggest one is AWS that you already have, I guess.
Uh-huh.
Okay,
AWS, we have the the architect level.
that is fine. That is fine. Architect, they are assuming that architect will know about DevOps as well, right? As an architect,
Right.
AWS solution architect, you must have studied those services as well, right? DevOps services, the basic ones,
Uh,
AWS.
yeah, I mean, like when we were studying, I mean, it was very kind of, difficult to grasp, what was going on. But when we are doing DevOps, you can understand, okay, this is why we were doing that in the, architect
Mm-hmm.
level. So,
Mm-hmm. Yeah. So yeah, for AWS you can do any course. AWS Solution Architect you have already have, so that is good. Then you can do CKAD you can do
CKD.
certified, yeah, certified Kubernetes administrator. That certification you can do.
Uh,
Okay, so most of the calls that you get in an interview are based on these two only. If you are AWS certified and Kubernetes certified,
yeah.
then you are they will assume that you are like God.
Okay. So these two are good, right? So, okay, then let's
Mm.
focus on, I will try to
These
look
two
at
are
that.
good. These two are good. So for Kubernetes, it's a huge, like for it will be
Mhm.
30-40 hours of Kubernetes only. It's a huge topic. Kubernetes is huge.
Okay.
Okay, but it is easy as well. Okay,
Yeah.
it's not very difficult. Okay, I'll give you a brief overview. What is it? So
Hmm.
you see Docker. So we saw till now we have seen Docker. Okay, just go with the logo, you will understand what Kubernetes is. Okay, so Docker logo is go. So Docker logo is
Like
this,
ship. Yeah, yeah, like
right?
that.
You
Yeah.
see a ship.
Container ship.
You
Yeah.
see a ship and you see all the containers. Okay, this tells you
Yeah.
multiple things. Okay, so first
Yeah.
thing is Docker is lightweight. Okay, the containers are lightweight. There are so many containers in a single ship and it can be shipped. So that means it is very lightweight. Okay.
Yeah.
And for Kubernetes, you have this logo. You see
Hmm.
this logo. This logo is that of the ship, right? The where you can how you
Ah, yeah.
control the ship, how you control the ship.
Yeah, exactly.
So
Yeah,
that's what
correct.
that's what Kubernetes is doing. Okay,
Uh-huh.
that will control all your containers.
So
Uh-huh.
steering, right? Ship steering.
Steering, yeah, it's a
Yeah, yeah,
steering,
yeah.
it's a ship steering. Okay, so that's what Kubernetes is doing. Kubernetes is container orchestration. Kubernetes is
Mhm.
container orchestration tool. Okay, so like you have only if you are using Docker, only if, until now what we have studied multiple containers. Okay, we can create hundreds and 500s of container in our single EC2 instance. Okay, and in our, if let's say we have 5 or 6 EC2 instance, in every EC2 instance we have 400 500 containers. Okay, imagine how many containers we are having. 2000 containers we are having. Okay, so imagine now how we were creating containers using the run command, correct? Docker run hyphen it. So imagine running this command 2000 times. And plus there'll be so many things, uh, how to manage it. For example, like everything in the every application in that you see on the web, like for example Hotstar, Netflix, okay, everything that you are seeing, that is using containers right now. Okay, but how are they managing it? How are they manage? For example, Hotstar. Okay, when cricket is getting streamed there. Okay, when cricket is getting streamed there, you see, there are millions of people logged in at the same time. Okay, during the last overs, during the last 1 or 2 overs, the number of people even get increased at that time. So they are running containers, correct? They are running containers. So all these containers are handling some amount of users. So if the number of people who are logging into this application are increasing, the number of containers are growing. Okay, so here we also have auto scaling, concept of auto scaling here on the containers.
Mm.
Okay, you cannot have thousands of containers running every time, correct? Similar
Ah,
to
okay, it will be
similar
expensive, right? To
correct, it
do
will be
that.
expensive, it will be expensive, it will be putting load on your EC2 instance,
Yeah.
like as well as if let's say if there are uh, uh, only one application that is going to, if they are not properly used, let's say, okay, if you already have created 100 containers and you just use only 2 containers, rest 98 containers are just wasting your memory, correct? It's just wasting everything. So so that's where auto scaling, use of auto scaling comes into picture. So like the same concept of auto scaling that you have in EC2s. Okay, when you need it, you scale up, you scale out. Okay, and when you don't need it, you delete those EC2 instances. So that's what happens here in case of containers. So what when you need some more containers, you just run multiple containers, and when you don't need it, you just delete those containers. Okay, so that's where comes the need of so Docker does not do all these things by default, auto scaling thing and all those things Docker does not do. Okay, so you need something else to do it. Okay, so that's where Kubernetes comes into picture. Okay, this is auto scaling is just one thing. Okay, there are many things. There are many things. You will see there are many things associated with that Kubernetes helps Docker to do. Like people these days confuse that Kubernetes and Docker are the same thing. No, they are not the same thing. Docker is a container. Docker is an engine. It's a container engine. Okay, with Docker you can create multiple containers, and to manage all those containers you need Kubernetes. Okay, so there are multiple tools similar to Kubernetes available in the market. Okay, so Kubernetes were developed by Google. Okay, that's why initially it was not available to AWS. It was available to GCP in the starting first. Okay, because it was developed by Google, correct? So now that then so it was only available to GCP. Okay, the Google Cloud Platform. Okay, but then GCP guys thought that let's make it open source. Okay, so that people are able to contribute to it. Okay, so that the library gets enriched and more people are using it. So after that they made it open source and they donated it. Okay, the whole Kubernetes code they donated to this Google Cloud Native. This they have a separate segment. They donated it to that. Okay, then it got available to Azure and AWS. Okay, so so similar to Kubernetes, I was saying similar to Kubernetes, you have multiple tools available in the market. You have a tool from Docker as well. Okay, you have something called Docker Swarm, SWARM. Okay, so you have a tool called Docker Swarm. Okay, so that is nothing. Docker Swarm manages the Docker containers. Okay, Docker Swarm also manages a Docker container. Okay, and it is very good to use with Docker. Okay, because the container engine we are using Docker to create images, to create containers, correct? So to manage the containers, you can use Docker Swarm as well. But this did not become very popular in the industry. Okay, this did not become very popular, but Kubernetes became more popular than that. Okay, now Kubernetes can manage the containers, not only Docker containers. Like I told you, right? Similar to Docker as well, there are multiple tools available in the market. Okay, like for every DevOps tool, there are multiple competitors, correct? For Docker also has many competitors, but Docker is has the most amount of market share. Okay, so Docker is used for creating containers. Similar to Docker, you have container D and and many. There are many things. Okay, available in the market. Okay, that also you can use to create containers. Okay, now if you have containers, now you want to manage those containers. You can manage those containers using Kubernetes. Okay, and Kubernetes is cannot even only manage Docker containers. It can manage the other containers as well. Okay, so Kubernetes became more popular than Docker Swarm. Docker Swarm is similar to Kubernetes. Clear? Clear now?
Yeah, it's clear
So
now.
there is
So
a AWS specific thing called ECS. Also you must have heard about this name. ECS, Elastic Container Registry.
yeah.
ECR Elastic Container Registry and ECS is Elastic Container Service. Okay, and then ECS is also similar to Docker Swarm and Kubernetes. Okay, with ECS also you can manage containers. Okay, so depending on the use case, you can use whatever you want. So we will study Kubernetes because that is the most popular thing in the market. So it is taking almost like everyone in the world is using Kubernetes now. Now, people somewhere you will see Docker Swarm being used uh, and ECS being used. Like people who are stuck to AWS, like who are sure that they don't want to use anything else, they want to always stay in AWS. So they will use ECS. They can use ECS, but Kubernetes can be used with GCP. It can be used with AWS. It can be used with Azure. Okay, and uh, it can be used without cloud as well. Okay, yeah, you were saying something. Yeah, any questions?
no, I was just because so far what we understand is Docker is not same as Kubernetes, right?
Right.
And Docker engine is still it runs on top of the OS,
Mm-hmm.
right? And then Kubernetes is like an orchestration tool, yeah, that
Correct.
controls the
For
engine.
yeah, for controlling all the containers, for orchestrating all the containers.
Containers. Okay. It doesn't control. It doesn't control the container engine, right? Just
No,
the
no, 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 no.
on
Just the
the
containers.
containers.
Just the
Okay.
containers. Just the containers. Okay, just to make your life easy. Okay,
Yeah.
because just imagine like 2000 containers you have to manage. How will you
Yeah.
manage it?
Mm,
So you create clusters. Okay, you can create clusters. That cluster contains multiple containers.
yeah.
So managing in the sense, what does it manage? I mean, uh, the communication between the containers.
Everything. Yes, that as well. Managing the container. So we have a concept of pod in Kubernetes. Okay, in Kubernetes you have a concept of pod. Okay,
No, when
and
you say
inside a
manage, what does it really refer to? Orchestration. What does that really refer to in terms of clear technical terms? I mean,
hmm. So
it's a
it can
manage a
refer to
container.
yeah, like one thing I talked about auto scaling. Okay, one thing I talked about auto scaling. That thing.
Okay.
Okay,
Mhm.
second thing, you can manage the connectivity between multiple containers. Okay, for example,
Oh,
your application that is running inside one container can be accessible to multiple containers. Okay, that you can manage. You will have you Kubernetes can have its own networking. Okay, we have a component in Kubernetes that can do the whole networking, assigning IPs to your containers. Okay, so right now what we are doing is we were just um, using the IP of the host machine to refer to those containers, correct? So with this Kubernetes, we have a component in Kubernetes that will assign IP to to your pods. Okay, there we have a concept of pod, and every pod can have multiple containers running. Okay, that will come into detail when we are discussing architecture in the next session. Okay, but today we'll not start Kubernetes a lot because it will get you confused. So just for now, assume that Kubernetes is something that orchestrates, that is a container orchestration tool. Okay, that is just a container orchestration tool. You can use it to do manage your containers. Okay, manage the auto scaling, manage the networking, manage the volumes. Okay, how data is shared, how your containers are being accessible to the world, how inter container communication. Okay, load balancing your containers. Okay, load balancing also a part.
So so
Hmm.
when you say managing, like, I think more like, deploying automatically, scaling automatically, and
Hmm.
those kind of
Correct,
functions,
correct.
isn't it? Yeah.
Yeah, deploying, scaling, load balancing. Load balancing is also important feature. For example, you can have multiple containers. Okay, you can create multiple containers of the same application.
Okay.
Now, similar to EC2, uh, remember that EC2 instance, how we used to do? We used to create multiple EC2 instances. And when a
Yeah.
request used to come in, a load balancer used to distribute the request among
Yeah.
different EC2 instances, correct? So
Yep.
that's
Yep.
what we can do here. We can have 10 containers running, and whatever the request is coming, with the help of Kubernetes, we can distribute our request that is coming to any container among different containers. Okay, that also we can do with the help of Kubernetes. So Docker could not do it. Docker alone could not do it because Docker is just a container creation tool. It cannot manage a container. Okay, Docker was just creating a container. Correct? We are just running a container using it. So Kubernetes, Docker Swarm, ECS, so all these things we are using to manage a container, to orchestrate. All these are container orchestration tools. Okay. Okay.
So how different is it from load balancers? I mean,
Load balancer is one of the things that it does. It is just one of the
uh-huh.
things. Load balancing is
Yeah.
just one of the things that Kubernetes is doing.
Okay.
Mm. So you will see Kubernetes is very
So
Yeah.
interesting.
Kubernetes does the load balancing as well.
Yeah, yeah, it does load balancing as well. Like everything you can imagine,
Okay.
imagine those containers, and whatever you can do with those containers, that Kubernetes will do it for you. Create auto scaling, deleting, scheduling containers. You can schedule your containers that okay, this container has to start at this time and end at and stop at this time. It has to run for this particular time. Okay, and
And okay, we can give traffic thresholds, right? Like when the traffic is really high, you can
yeah, yeah,
spin
yeah,
a new
same,
container.
right,
Yeah.
right, right, right. Auto scaling, that's
Yeah.
what auto scaling is, right? You can specify threshold. After this,
Mm-hmm.
if this 80% of utilization of this is done, then you can create another container, start running another container. Okay, you
Yeah.
can
Okay. So
start
even like,
creating. Hmm.
and then it can remove the containers when it's
You
not
can
required.
delete, yeah, you can delete the containers if the threshold comes below, if it goes
Okay.
below the threshold. Okay.
I mean, this is what load balancer is doing. Maybe when we go more in detail, I'll
No, load
understand.
balancer is not, load balancer will not delete your EC2 instances, right?
Uh-huh.
Load balancer is not deleting your EC2 instances. It is just,
Yeah, that is load balancing the traffic.
that is load balancing the traffic. That's it. Auto scaling can delete your traffic. Auto scaling can delete your EC2 instances. If your EC2 instance is
Yeah.
not required, it will stop those instances or it will terminate those
Mm-hmm.
EC2 instances. Okay, so the characteristics of load balancer, characteristics of auto scaling, characteristics of like managing the volumes, you will see how the volumes are getting managed. Okay,
Mm-hmm.
how the volumes are being shared. Okay, you will have the concept of resource quota. Okay, so every container can have its own quota. Okay,
Okay.
for example, you have 2 GB of RAM that you want to assign to a container. Okay, now you want that it should not go beyond that. It should not use more than that. Okay, now
Mm-hmm.
then you can assign a quota. Okay, these things all we'll discuss, resource quota,
Yeah.
and these things we'll discuss in detail. We'll discuss
Yeah,
the
I mean those
part as well.
were done in separate in AWS, right?
Hmm.
Amazon EC2 auto scaling, and then we
Hmm.
had the load balancers, different load
Right.
balancer, ELB, and those
Hmm.
kind of load. Yeah.
Right. Right. Right.
But this has just one which can do all of it. Looks like.
Right.
Right?
Right. 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 It
Yeah.
can do everything. It can do everything.
Okay.
So this is very, very good. Kubernetes is very. You will see how powerful is it. How powerful it is.
Okay.
Kubernetes is very powerful. That's why you have a separate certification, right? It's a huge topic. It's a huge topic.
Okay.
It's like a 30, 40, 50 hours of course you will have for this. So we'll cover
I mean,
most
they
of it.
have done
Mhm.
from a physical server. We have come to so much of modification of the server in terms of like beginning with this VMware
Mm,
hypervisor.
mm,
Then we come to this. We studied today. What is that?
mm.
This Docker.
Containers.
Then we come to this again, the managing the containers. So
Mm,
three levels. So now the Kubernetes is going to do everything, whatever a load
mm.
balancer, the auto scaling, everything. Yeah.
Right, right.
So it's basically you're creating a server at a very granular level and making it virtual, scalable, whatever we can
Mm.
think of.
Right, 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 right.
Basically, that's a
Exactly.
from that has come a long way from a physical server.
Right.
Everything possible, what one can imagine with a server, we are doing everything to that.
Right. Everything.
Yeah, yeah. Cheers. Thank you.
Okay, let's connect tomorrow. Tomorrow I'm a bit doubtful whether we'll have a session tomorrow because uh I think I'm having some fever. I started having fever in the morning, but I think I'll take a rest because so that next week I'm fine. So if I don't take rest, the
Yeah,
next
yeah,
week will
that's
be like
fine.
that
Yeah,
only. Okay, I'll based on my
you take.
health, I'll
Yeah.
just update tomorrow. Okay, I'll update in the chat if you're going to have the session or not. But anyways,
Okay.
we had this session for I guess continuously we are having sessions since 2 to 4,
Long time.
5, 6, 7. I guess 7 sessions we had six sessions. I guess we have continuous. Okay, Ansible, Docker for two Ansible, two Docker, and one today. I guess 5 continuous sessions we had. Okay, so we can have a break if you want. So I'll
Yeah,
also
yeah.
gear up
That's
and like
fine.
next Saturday we can meet with.
Okay. You take a rest tomorrow, then we
Mm,
can carry on to day after
okay.
tomorrow. That's
Till then
fine.
you
Yeah.
can also revise
Go
and
through this. Yeah.
yeah. So the topics which are pending is one is Kubernetes. Okay, we'll see how much we want to spend time on that because that is never ending topic. Never ending means it'll we cannot cover it in just 4 or 5 hours that we have specified in the syllabus, but I'll try to cover what is required. Okay, what will be beneficial for you to crack an interview or start working on Kubernetes. Okay, I'll tell all those things. Okay, plus there are like hundreds of things in every tool. There are hundreds of things that you can explore. Okay, that you can always do. Okay, so that part is pending. After that, we'll see some AWS DevOps services, and then we'll come to a mini project. Mhm. Okay, then let's meet tomorrow if I'm fine or next Saturday. Okay.
Yeah. Take care. Yeah. Bye bye.
Okay.
Okay. Thank you.
Thank you. I'll share this recording. Okay.
Bye.
Okay. Thank you. Bye.